Okay, in this tutorial we're going to be looking at circle theorems. So first let's look at the language of circle theorems. If I draw a circle here, we know that the length between the centre and the circumference is the radius. The length from circumference to circumference, which goes through the centre, is the diameter. The line which touches the circle only once, drawn here, is the tangent. And this, we know, meets the radius at 90 degrees. So the tangent always meets the radius at 90 degrees. Next, if we put 2 points on a circumference and draw a line between them, that line is called a chord. Okay? Now, notice how I've drawn 3 points. We're going to look at what it means to subtend an angle. This is one of the biggest sticking points for people looking at circle theorems. So, if I start to, if you imagine that this chord here, that yellow chord, is pulled out. So now I get to the green line there. If I pull it out a bit further, if I keep pulling it out, eventually I'll get to that point on the circumference there. Okay? So we say that that angle there is subtended from the chord. Okay? The angle there is subtended from the chord. So this angle is subtended from the chord AB. Okay? Let's look at that in a slightly different way, just so you get a feel for the language there. So I could draw a chord between A and B, and that angle there is subtended. We might call that C. So I could say that the angle ACB, now you should have watched the previous video and you know what ACB means. It means if I go from A to C to B, I will get that angle. I draw a little hat on the C. So this angle is subtended from the chord AB. Okay, another piece of language which I haven't mentioned yet is either side of a chord we get segments. The smaller segment is called the minor segment, and the larger segment is called the major segment. Don't get confused between segments and sectors. If you look at that blue segment there, it looks a bit like an orange segment. That might be one way to remember it. This video we're going to be looking at circle theorems. Now these are theorems that you will need to learn and remember. I won't go through the why in this video, why these theorems are true. I'll just go through what they are. So here we have the white line there is the diameter, and that yellow angle is subtended from the diameter. So if I say if an angle ACB, that yellow angle there, is subtended from a chord AB, sorry. So that angle is subtended from the chord AB. The yellow angle is subtended from the white chord. And let's say that is 90 degrees. So if that angle is 90 degrees, then the chord is the diameter. Okay? If I just back up there So, saying that again, if an angle ACB is subtended from a chord and the angle is 90 degrees, then the chord is the diameter. We can say the same in the opposite direction. So if I have a diameter and I subtend an angle, the angle will always be 90 degrees. Next. Okay, so I've subtended 2 angles from that yellow chord, the green angle and the white angle. Okay, these angles, so the angles ACB and ADB, the green angle and the white angle, I've written them in green and white to help you out. They're in the same segment, so they're both in the major segment and subtended from the same chord. That means, therefore, they are both equal. So those angles, that white angle and that green angle there, they're both equal. So ACB is equal to ADB. That's your second circle theorem. Now, I've just named this theorem the batwing theorem, just because they look a bit like bat wings. Yeah, your third circle theorem. So, what I've done here is the green angle there is an angle subtended from the chord at the centre. Okay, so it's just subtended at the centre. The yellow angle is subtended from the same chord, but it is at the circumference. Okay? So the theorem is the angle subtended at the centre is double the angle at the circumference. Now, pictorially, I might say the green angle is double the yellow angle. That's what I mean. The green angle there is double the yellow angle. I might call this the arrowhead theorem because that looks a bit like, each one looks like a bit like an arrowhead. Okay? The next circle theorem is one of the most complicated. So what I've done in that diagram so far is that kind of pinkish line is a tangent. The green line is a chord which meets the tangent. And this blue thing is an angle which subtends the green chord. Okay? So that's a tangent, this is a chord, and this is the subtended angle from the chord. Great. So this theorem, if we look at the red angle, that is the same as the blue angle. So how might I write that in words? Well, I say the red angle is the angle between a chord and a tangent. You can see that, it's between the chord and the tangent. And the blue angle is the angle subtended from the chord. And it is in a different segment to the red angle. So you can see how it's in the major segment, which is in a different segment to the red angle. Now the name of this theorem, since it's in a different segment, we call this the alternate segment theorem. Okay. The final circle theorem, we draw a quadrilateral inside a circle, A, B, C, and D. If I mark the angles, a green angle, a blue angle, a red angle, and a yellow angle, then the theorem says that opposite angles in a cyclic quadrilateral add up to 180. Okay? A cyclic quadrilateral just means that the quadrilateral has been drawn with the points on the circumference of a circle. Now looking at the angles, that means the yellow angle plus the red angle, they're the opposite angles, they are equal to 180, and the blue angle plus the green angle are also equal to 180. Okay. Now the number you were looking for at the end of this video is the number 6237. 6237. There are all the circle theorems. We're going to apply these circle theorems to questions in lessons, and I might follow up a video with how to use these circle theorems in questions.